group number 1. I'm going to be presenting on geothermal energy. I'm Andrew Pollack. This is Linda Casina, Scott Lundquist. Start off first. Geothermal energy is similar to solar energy in the fact that they both produce heat energy from nature. The difference is that solar energy comes from the sun and geothermal energy comes from the interior of the earth. That's basically what it means. Geo means earth, thermal means heat. Geothermal energy goes through several steps before it is actually useful to us. First, the Earth's core continually produces heat in excess of 9,000 degrees Fahrenheit. This kind of high temperature can easily melt the rock in the mantle and form a substance called magma. Since the magma is less dense than the rocks, it rises towards the crust, bringing heat with it. Magma, which we know as lava, occasionally reaches the Earth's surface. Many times the magma will pool beneath the Earth's crust, which is where it heats rocks and the rainwater. Just like magma, the hot geothermal water sometimes makes its way to the Earth, and this is known as a hot spring or a geyser. One of the more famous geysers is Old Faithful in Yellowstone National Park. This erupts about every 65 minutes and shoots out water at or near boiling point. One of the more recognized, it is uncommon for this hot water to reach the surface, and most of the time it stays trapped in the rocks and cracks below the Earth's crust. This area that traps the water is known as the geothermal reservoir, and this is the area we extract our geothermal energy. This is a fairly simple diagram of how we get the energy. They pipe out the heat from the reservoir in the rocks, where it is turned into a useful resource, and then pipe back down to the reservoir through the injection well to be reheated and used again. Volcanoes, fumaroles, hot springs, and geysers are all sure signs that geothermal energy is below the surface. Most active geothermal resources are found along the border of the Pacific Ocean, known as the Ring of Fire, which would be this whole region right here. This area is also the most active for volcanoes as well. Basically, volcanoes and geothermal energy go hand in hand with each other. Since most geothermal reservoirs are beneath the surface, the best way to be certain you have found one is to drill a well and test the temperature deep underground. Scott's going to talk about some of the different power plants that are used.
All right. All geothermal plants usually have this. They have the same basic idea. Yet there are different kinds of plants. For the first one, this is a dry steam plant, which just uses steam from the reservoir to turn the turbines and generate electricity. This was the first use. This was the first use of geothermal energy, and started back in the 1960s. This plant was known as the geyser, and has become the most successful alternative energy source project in history. The second type of plant is called a flash plant. This power plant brings hot water in excess of 300 degrees Fahrenheit to the surface, where it flashes into steam in the separator, and this powers the turbines. And the final type of power plant is called a binary power plant. A binary power plant uses hot water between 250 and 360 degrees Fahrenheit, and it has to pass through a heat exchanger where it's transferred into a second liquid known as isopentane. Isopentane can boil at lower temperatures and also produces steam, which ultimately powers the turbines as well.
Okay. The first geothermal energy use in industry was during the late 18th century near Pisa, Italy. Steam coming from natural vents was used to extract boric acid from the hot pools that are now known as the Larderejo fields. Then, in 1904, the Italian scientist Pier Ginori Conti invented the first geothermal energy power plant in which steam was used to generate the power, producing 250 kilowatts. It was put in operation in 1913, and geothermal power production has since increased continuously up to the present value of 810 megawatts capacity and 1,011 megawatts running capacity. A little bit of history of geothermal energy in the U.S. The first geothermal plant in the U.S. started in 1922 with a capacity of 250 kilowatts, which could light the streets and buildings in the area. This plant didn't last very long due to the little power output compared to other sites across the world. Also, it had some technical problems that had to be shut down. During the 60s, the first large-scale industrial geothermal energy power plant was constructed in San Francisco and produces 11 megawatts of environmentally friendly renewable geothermal electricity. Today, there are more than 60 geothermal power plants operating in the U.S. at 18 sites across the country and many more across the world. Geothermal power today supplies less than 1% of the world's energy and is expected to supply 10 to 20% of the world's energy requirements by 2050. Geothermal power plants today are operating in about 20 countries, such as Mexico, New Zealand, and El Salvador, among others. Now let's talk about some disadvantages of geothermal energy. The main disadvantage of building a geothermal energy plant mainly lie in the exploration stage. During exploration, researchers will do a land survey and then post their findings to the company that contracts the survey. Many companies who order surveys are often disappointed, as quite often the land they were interested in cannot support a geothermal energy plant. To extract the heat, we have to find certain hot spots within the Earth's crust. These are very common around volcanoes and fault lines. Some areas of land may have sufficient hot rocks to supply hot water to a power station, but what if these areas are contained in harsh areas of the world, near the poles or high up in mountains? Some very good proven spots have been found in New Zealand, Iceland, Norway, and Sweden. The questions that are usually asked during this survey are, is the rocks soft enough to drill through? Do the rocks deep down contain sufficient heat? Will this heat be sustainable for a significant amount of time? And is the environment fit for a power plant? Another disadvantage is the energy extraction. In many cases, a site that has been extracting steam and turning it into power for many years may suddenly stop producing steam. But this is in some cases, because in most of the cases, the steam can last for more than 25 years. So, okay, now let's talk about some advantage of geothermal energy. The cost of the land to build a geothermal power plant on is usually less expensive than if you were planning to construct an oil, gas, coal, or nuclear power plant. The main reason for this is land space, as geothermal plants take up very little room, so you don't need to purchase a larger area of land. Another factor that comes into this is that because geothermal energy is very clean, you may receive tax cuts and no environmental bills or quotas to comply with the country's carbon emission scheme. No fuel is used to generate the power, which in return means the running costs for the plants are very low, as there are no costs for purchasing, transporting, or cleaning of the fuel you may consider purchasing to generate the power. The overall financial aspect of this plant is outstanding. You only need to provide power to the water pumps, which can be generated by the power plant itself anyway. How is the time? How time? No more time? Okay, only for the conclusion. 1 minute for the conclusion. Yes, conclusion. We don't have time. Yes. Okay. Geothermal energy is natural, clean, cost-effective, renewable source of energy. We have to support every effort to promote this energy and take all the advantage it offers. Doesn't need large areas to build a plant, is cost-effective, it is very clean. The advantage of geothermal energy surpass this disadvantage. Geothermal energy is a sustainable solution, meaning that we can exploit them for long periods of time, more than 25 years, basically with just maintained investment. Geothermal energy can reduce the dependency of fuels in those areas where it can be exploited and is an effective way to reduce carbon emission without significant public health risks derived from their use. Thank you.
There's another conclusions. Okay, so go ahead with your conclusions.
Geothermal energy is a very clean resource, like she said. Get the best of both worlds. We cut back on fossil fuels, and in return, we reduce our emissions. The power plants are very environmental friendly when it comes to operating and building the plant. There are no significant signs of a plant if one were to be demolished, whereas a coal mine would have a hole in the earth. Since these power plants are in our own country, this leaves the money in our country. There is no need to pay other countries to export anything to us because we don't have to depend on them for anything. One of the biggest concern is when a reservoir goes cold or runs out of steam. This usually happens when the power plants run too much water down to the reservoir to be reheated. Just like anything, if you put cool water on a heat source, then it will cool it down. Overall, I strongly believe that geothermal energy has been one of the most successful alternative energy resources and even beats out ethanol in plants like FutureGen.
Conclusion?
Yeah, I'll keep it short. I mean, my conclusion is basically just saying what they were saying. That is, I mean, I think it's probably one of the new energy sources of the future. It's interesting because one of the houses back where I live in Chicago is actually using geothermal energy to heat their house. And it was just interesting watching them build the house because it took them like an extra month or two just to set up the entire geothermal system before they actually started building it. But I don't know. I just think it's one of the main clean energy sources that we'll probably be using.
That's all? So let us give them a hand for the questions. Did very well. And for the questions, we have this mic, so we have your voice coming to the camera. If you have a question, ask for it. Yes, please. Pass it on and keep it on all the time. Yes.
Scott, you said you lived in a house that has geothermal?
No, they're building one like right next to me. They tore down an old house, and one of the people that are building it are using geothermal, and they're setting up solar panels on the roof. They're going like all green on their house.
Well, my question, which you may not be able to answer, is how comfortable is geothermal in a house compared to other energy sources? Do you guys have any idea?
I don't know. I've never been in one. It's fairly new out, but I would think it'd be kind of comparable to the old radiation where it's pumping hot water through pipes and heating the house that way. Be my best guess, but I can't honestly answer because I've never been in a house that has it.
Now, let me just ask here, is it an energy just for heating per se or only, or it is for lighting and other stuff?
Electricity, yeah, there's several
so you can
different
produce
things,
electricity?
Yeah. The steam from the heat produces electricity by powering turbines and different things. So yeah, lighting or...
So the steam comes from boiling water. So you use it to heat water and then the heated water will do that or what? Or the steam comes from
the heat, one of the... let's see here. This here is bringing up the heat from the reservoir into like a brine. And then the steam from that goes into the turbine, which powers the generator.
Powers the generator,
yeah.
Okay. Any other questions? Yes, please pass the microphone for him. In the back.
So as we are going to dig huge holes into it, so what are the chances for earthquakes or something like that? So is there any chances for that? As we are going to dig huge holes or something into earth?
Would you say chance for cracks?
No, earthquakes.
Earthquakes.
Oh, earthquakes.
Earthquakes.
Will an earthquake destroy it, or will it cause an earthquake?
So, what are the chances or causes?
deep down wells. So what are the chances of the steam coming out and lava coming out in the cities?
They're relatively small pipes going down into the earth. The chance of like an earthquake or magma coming up through the pipe.
Yeah, something like that. But I don't know. Like, is it possible? Like he said, there's a house being built in Chicago. So like, do we have any kind of research being done based upon that, or it's just an attempt? I don't know if Chicago actually has magma, or, has a belt or something which you specified.
I mean, I'm trying to figure out what country uses. I mean, there's a country that pretty much they use only geothermal to heat.
New Zealand.
Yeah. Well, I mean, they don't have a problem with it. Chicago's not going to have a problem with it. I mean, the pipes that they put down there they're not like giant pipes that they're just going to shove down there. Nothing is going to pop up from it. It's just going down to a heating well, pretty much.
Any other questions? Heated questions?
Very heated.
Okay, so thank you very much.